if you've been using Unity with visual scripting for some time now, then you might have ran into the issue that there aren't an awful lot of resources out there about visual scripting. So you might have looked for tutorials and example code and so on, and you might not have found anything in visual scripting, or maybe you found only very few things in visual scripting and you found mostly things in C#. So my goal in this video is to tell you how to look at a piece of code written in C# and be able to transcribe it or translate it to visual scripting, so that if you find a tutorial that is written in C#, you can more or less translate it to visual scripting. You might still need some additional information. There are some things that are different and that I'm probably not going to cover in this video because I cannot cover everything and every corner case. But I'll give you an overview. And here I just have a very, very simple sort of example of what a Unity script is in C#. So this is like the template that Unity gives you when you create a new C# script. And as you see, you have something, private, whatever. Let's not care about this for now. You have something called start and something called update. And those are exactly the same things that you get when you make a new visual scripting graph. You've got something called on start and something called on update. And the clue here is they represent exactly the same thing. This node will be executed when your game starts, or more specifically, when the script object is enabled. That's the same thing for this start thing. So there's something called start, something called update, something called start, something called update. Okay, so one thing that you will see in C# a lot is something like this. And there's again this public, sometimes it's going to be private, and sometimes it's going to have something like this on top of it. You can, for the most part, ignore this stuff. And what this is a variable. This is exactly the same kind of variable that you can make here in your Blackboard. So I can go here and say my number and make it a float and give it a value of 5. So that's the same now as this variable. It's a type float. That's the name. That's the value. Whenever you see an equal sign, that means assignment. That means I take whatever is on the right side of the equal sign and put it on the thing that's on the left side. In this case, I store this value in a variable. Now, the whole thing with like private and public and so on, I should say it doesn't matter as much in visual scripting as it does in C#. For the most part, you can make like most of your variables object variables. So if you see a variable that looks like that, it can be an object variable. If you see something that looks like that, it can also be an object variable. If you want to make it a little bit more exact, then maybe it should be now, when it comes to different kinds of access modifiers, so like this private, and sometimes you will see public, sometimes you might even see protected and all this stuff. So these kinds of words like public, private, and protected, they are not as important in visual scripting as they are in C#. For the most part, you can make all your variables object variables. So you will see these kinds of things, private, and you will also see other things like this, public game object, a prefab or something. This is another variable. Again, a variable has a type and a name, and it can have a value or not. So this would be the equivalent of doing this, a prefab, and the value or the type would be game object, and there is no value, right? The value is none. It's just empty. Here we don't give it a value. That's basically the same. Most of the time, the variables in a C# script are going to be declared, so they're going to be written down at the top of the script. That means between this part where it says class something, tralala, and sort of the start function or some other function that might be here, which then has these like curly braces, right? So usually the variables are going to be at the top between this class stuff and then the first function. And the way you can tell a variable apart from a function like this is that the variable has the name, maybe a value, and then a semicolon, right? This, like I said, is a function, and this has, first of all, parentheses, and second of all, curly braces. So that's not a variable. And what these things are in visual scripting is nodes, right? So we already saw the start node and the onUpdate node. And sometimes you might see some other things, like I could go here. It's very easy in C# to make my own functions. Like I could say public void do a thing, right? And I forgot a curly brace there. And now this is my custom function. In visual scripting, you can also do this. You can make your own nodes, but it's not as intuitive. But you could definitely do that. How do I do this? I basically create a subgraph like that, right? And I can say, okay, edit graph. I can give it a name, do a thing, whatever, right? And then it has an input and an output. And I can then say that I can call it, right? So I just have like an input here. Something like that. And then I can go here to the output and say, I need always like a name and stuff. So it's a little bit more complicated than in C#. But now I've got a graph, I've got a subgraph. This is basically a custom node that I just created. And now I can call it, for instance, on start. I can say on start, I want to run whatever is inside of this box. And I can do the same in the code. So sometimes you will see things like this, right? That is exactly the same. So that's just saying, okay, this is going to happen after the start. So start gets executed, and whatever is inside of this start block gets executed. And then it goes into this thing, and then it runs whatever is inside of here. So you can think of the start as like a block of commands or instructions. And then everything that's inside of this, which in visual scripting is represented by this like flow chain with these wires and stuff, is going to run. So it goes to a node, and then this node does something, right? Which is then inside of here. And here you could, just to be clear, here you could do whatever you want, right? You can use any nodes that you like, right? And then it does that, and then it goes to the next thing, right? So then it goes to the next thing. Let's say we log something to the console, and we log, done, right? So we start here on start, it goes in there, does whatever is inside of this do a thing graph, which is going to log a message, right? Then when it exits, it goes to the next node. And then that node does something. That would be the same as here in my do a thing here. I could also, here I print doing the thing, right? And here I can do that in code. So I just go debug.log. That's not what I wanted. Doing the thing. So now when I am inside of the start, I'm going to this node and I do what's in there, right? So I then do this node. But then after that's done, we just exit, right? So we go into the exit, which basically continues then here on the parent graph. What this means is, okay, I reach the end of this function in the code. I go back here and then I do the next thing, which is then this log. So in the code, we go top to bottom. So we do the first line, we go in there, we do whatever is in there, then we exit. So we're back here, and then we do the next line. In Visual Scripting, it goes left to right. We start on start, we do the first thing. After it ends, we do the second thing, and so on. And you might have also noticed, as I was doing that there's this difference also in how you give inputs to nodes and to functions. So in C#, you will see this kind of thing where there's like parentheses, and inside of the parentheses, there's something. In this case, there's text, there's a string, right? This is basically how you, if we think of this as a node, this is how you pass data into the node. In Visual Scripting, we have these ports here on the left of the node. So another thing where you will see this is, for instance, if statements or if nodes. So in code, you might see something like this. And I'm just writing here true. It could also be false. Usually, you will not see a true or a false here. You will see some kind of calculation, some kind of comparison or something where the result will be true or false. But for simplicity, I'm just writing true here. And then you will see curly braces. Sometimes you might also see no curly braces, but it works the same. And then you will see inside of these curly braces something like this. So just for simplicity, I'm using another debug log, but something will be done inside of these curly braces. And that's the same as having an if node here, if node, and look, in the code, I have after the if, I have this parentheses with just the word true. And in Visual Scripting, I have again this input of the node here. And in this case, I'm going to make it also true, right? So that is the if true. So that's the value that's going to be checked. And then to mimic what I have in code, I do again a debug log with a string literal. So I'm just going to print true to the console. And if I want to do the, what happens if this value is not true, then you will often in code, what you will see is else. And then I will just copy paste this. Then something else happens, right? So if this value in the parentheses is true, this will happen. Else, so if the value is false, basically, then this will happen. So that's the same as doing this. I just duplicate that and I make that false, right? So now we have exactly the same code as in C#. So you see what comes in the parentheses is the input of the node. Another thing you'll see is something like this, where you will see basically a node, right? So a function, we have already learned that these are nodes with the parentheses. And then there are things that are separated by a comma. If we look at this node in Visual Scripting, it becomes very obvious what these things mean. So let me show you. We use the translate node, right? And it's this node here. Now in Visual Scripting, we have often an additional input, but basically you can see these three inputs, X, Y, Z. And that's exactly what these three things mean, X, Y, Z. Now, if you are actually writing the code or you have the code open in an IDE like Visual Studio here, then you can usually hover over the name of the function and you see there, you know, float x, float y, float z. So it's telling you, hey, this node needs 3 inputs and they are of this type, right? And they mean this thing. And then usually there's also, often there's also like a description. So it's telling, actually this one doesn't have, but sometimes there's a description for each parameter. Here it doesn't because it's quite obvious. It moves by this amount on these axes. Now, why do we have often this extra input in visual scripting? You might notice that here we just have like a node called translate, right? Whereas here we don't just have a node called translate, we actually have this thing before it. And what this means is that since the translate function or node operates on a transform, we need to tell Unity which transform to operate on. Which transform do we want to translate? And in this case, we are doing it to the current transform. This transform is a variable that represents the transform of this object where the script is running. In visual scripting, you know this as just the word this. So in visual scripting, you will say this dot translate, basically. That's basically the same. In C#, we have to usually specify which object we want to run on, even if it is this object, right? You will also find the word this in C#, but it doesn't really mean the same. It doesn't really work the same way. It works a little bit differently. And then, of course, you will also find sometimes scripts that manipulate other objects. So something like this. I do have here, let's say, a reference. So I would have here some reference to another object, another transform. So not the object where this script is, right? Not the object where the script lives, but some other object. And then I could move that object as well, right? And in that case, I would do something like that. Translate. The F just means that this is a float. If I would see this in C#, that means I'm using the transform or the translate node, but the target object is not this object, it's whatever is saved in this variable here. So in visual scripting, that would look like that. I would make a variable called another object. The type would be transform. So because that's the type there, type transform, that's the name. And then I would say, you know, translate again. And now the target would be the other transform, would not be this, right? And then it would be like, what did I write? 1, 2, 3. And the other one is 0, 1, 3, 0, 0, 1, 3. So now we have the same as we had here. So whenever you see things like transform dot, this really just means, hey, that's the current transform. That's the this, right? Other things you might see is game object, like that with a small g. Notice that this is also a lowercase t. So you might see game object dot set active, for instance. This really means the current game object. So this. In visual scripting, it would be just set active. This, right? That's it. Okay. And then if we would see something like the following in code, like that, now look, I am accessing the other object first. So I'm looking into the other object. I'm getting the game object of the other object, right? And then I'm executing this set active function inside of that game object, which belongs to the other object, right? So that would look like this in visual scripting. I would still have the set active node, but now the target is not this, but rather the another object. And then I need, from here, I need to get its game object. So you see the workflow is a little bit different because in visual scripting, we will usually start with the node, write the node first, and then we look for the target. Whereas in code, you will see first the target and then the node. So first the target, then you get the game object, and then you call the node. Okay, the next thing is when you see stuff like this in code. Let's say I have my number, and I say my number equals 4. So like I said in the beginning, whenever you see an equal sign, this means assignment. So that means I'm taking whatever is on the right side, so in this case a 4, and I'm putting it on the left side. So I take the 4, I put it in there, which since my number is a variable, what I'm really doing is setting the value of this variable. So in visual scripting, this would look like that. Set variable. The variable I'm setting is my number, and the value is going to be 4. So this is the same as this. And then there's also using variables. So when you use a variable, you just write its name as a parameter to something. So I could, again, use our trusty debug log function. So if you see something like this is just using the variable, which means it's getting the value of this variable. So it's retrieving it, reading it, and passing it to this log node, right? So that would be the same as doing debug log. And as the message, I get the variable. I do get variable. So I read the value, I pass it to the node. I read the value, I pass it to the node. You will also notice, or you might have noticed, that nodes or functions like this that have these parentheses, in visual scripting, they have these flow arrows, also called, I believe, trigger inputs and trigger outputs, right? So they can be triggered, they can be executed. Whereas things like get variable, get game object, a float, and stuff like that, these don't have these little arrows, right? So these are things like this. It doesn't have parentheses. You see, there's no like get game object and then parentheses. Yeah. So it's just the word game object. Here is just the number 4. Here is just the name of the variable. This is not actually executing something. It's not creating, it's not changing anything. It's just reading the data. Yeah. So that's always these, okay? Now there are a few exceptions in visual scripting. There are a few nodes in visual scripting that are sort of different from the code. And there are some nodes that don't exist in C#, but they are pretty easy to use. That sort of like difference doesn't really matter because they are intuitive to use. For the most part, you can be sure that if you see something like this with parentheses, it will be a node like this that you can connect to other nodes and it will be executed. And last but not least is when you see things like this. Let's say on collision enter, or on application pause, or whatever. You will notice a pattern here. They start all with on, right? It's a little bit inconsistent with the start and update. Or I should say start and update are the inconsistent ones. They are the exceptions, because these are just these Unity events, okay, that we have already been using. You have probably already been using in visual scripting. So we know them from here, from this events section, right? We have like physics, on collision enter. And you will see that it's a little bit different because here, in on collision enter, we've got basically one parameter. It's just this collision parameter. Whereas in visual scripting, we have here a bunch of stuff, right? And like I said, there are some nodes in visual scripting which are a little bit different than in the code, than in C#, but they do the same thing, right? So what this is, what you see here as all these pieces of data, is basically just what is inside of this collision. So this is a piece of data that actually contains a lot of other data inside of it. And what Unity has done is that in this node, they just sort of like unfolded, they unpacked the data that is inside of the collision, right? So for instance, here we have collision.collider, right? And that collision collider is just collider, right? So you don't have to go through this sort of middleman, you know, the collision and stuff. What else do we have there? Like impulse, or, you know, here's the impulse, right? And here you just have access to the impulse data directly, right? So that's it. And then there was also here on application pause, right? So that's another, there it is, right? And you see also here, there is a difference because here we have a bool. So we have a Boolean value, which is true or false, right? Which means whether the application is paused or not, right? So if this is true, then the application is paused. If the Boolean is false, then the application is not paused. And here we have something different because we have two different nodes for that. We have on application pause and on application resume. Okay, so just be aware that there are some things that are a little bit different, but at the end of the day, everything works the same because all that the visual scripting is doing is just generating the code for you. It's just generating the C# code for you, basically, right? Each of these nodes, they represent a little bit of code, of C# code. And whenever you create your graph and then you play the game or you export the game, all that Unity is going to do is just going to run the code that is sort of behind the nodes, right? The nodes, they are not actual code. They are just a visual representation of the code. So as you see, C# is really quite similar to what you're used to in visual scripting. There are some differences, like I said, you should be aware of them. And especially if you would look at a bigger project with a lot more code, then things can get quite different. But if you are just in a sort of beginner stage and you're just looking at simple tutorials, then this video should help you a lot to understand that code and applying it into your visual scripting graphs. If you want to learn more about C#, then subscribe to my channel. And if your questions are still not answered by this video, then feel free to comment because I will look at the comments and maybe some other people will also be able to help you in the comments. And if that is still not enough, then shoot me a message somewhere on social media or whatever, and I'll try to help you to create your visual scripting graph. Thank you, and see you next time.